moving with that angular velocity. Or basically what we have done is we are plotting the phase of the particle. Okay, and this omega is the angular frequency, or we can also call it the phase velocity. Is that clear? Okay, how do we draw the initial phase of the particle? Okay, so if the equation is x is equal to a sine omega t plus delta, if this is the equation of SHM, what is delta? Delta is the initial phase. At t is equal to 0, what will be the phase? How do we represent phase in a phasor diagram? The angle with the x-axis. Alright, so this would be delta. Is that correct? Okay, and then in time t, the particle is going to rotate a further angle omega t. Is that correct? So in time t, it is going to rotate a further angle omega t. So what is the phase of the particle now? Omega t plus delta. All right, so we assume that a particle is over here. Okay, so how do we find out the position of the particle? We take the vertical component, we take the vertical projection. Okay, and this will give you the position of the particle. All right, from this phasor diagram we can also find out the velocity of the particle. How do we do that? We draw a larger circle. We draw a larger circle, and what do we say? We say that this circle has a radius of a omega, because that is the maximum velocity of the particle. Okay, so the horizontal projection is going to be how much? A omega cos omega t plus delta. All right, so if I differentiate this, what do I get? I get a omega cos omega t plus delta. Is that correct? Okay, so this horizontal projection of the larger circle, that is going to give me the velocity of the particle. Is that clear? Okay, and what did we say? Two things. First of all, omega t plus delta is the phase, and a phase is the linear function of time. What does that mean? A linear function of time means it is going to move equal angles in equal intervals of time. All right, can we say that for position? Can we say that for velocity? No. Velocity is, or the position is, a sinusoidal function of time. Naturally, the velocity is changing at every moment, so the particle is not going to cover equal distances in equal intervals of time. Is that clear? How do we find? We find it by the projection from here. Is that clear to everyone? All right, so write this question. X is equal to 5 sine 20t plus pi by 3. X is equal to 5 sine 20t plus pi by 3. X is in centimeter, t is in seconds. All right, first question. When does the particle part A first come to rest? When does the particle first come to rest? Part B first have zero acceleration. Part B first have zero acceleration. And part C first have maximum speed. First have maximum speed. All right, the equation is given by x is equal to how much is that? 5 sine 20t plus pi by 3. X is in centimeter, t is in seconds. All right, now we can solve this question using equations, but a better method would be, or a much easier method would be, to use phasors. All right, so let's first try and solve it using the equations. All right, that of course you should know. Okay, so the question is, first come to rest. When it comes to rest, what is the position of the particle? When it comes to rest, what should be the position of the particle? That is the question. Absolutely, it should be extreme position. At rest means what? The position should be the extreme position. So x should be equal to what? X should be equal to 5. Is that correct? Okay, so I can substitute x for 5, and this will become 5 is equal to 5 sine 20t plus pi by 3. All right, this gives me what? This gives me sine 20t plus pi by 3 should be equal to how much? Should be equal to 1. That is 20t plus pi by 3 should be equal to how much? It should be equal to pi by 2. That means t should be equal to 1 upon 20 pi by 2 minus pi by 3. So this is going to give me pi upon 1/22. We can solve it using this one. Alright, what is the next part of the question? First have zero acceleration. Alright, when does the particle first have zero acceleration? The SHM never has constant speed. A particle executing SHM never has a constant speed. Alright, when will the particle first have zero acceleration? At the midpoint. Alright, the force is equal to minus kx. Is that correct? So when will the net force be 0? At the equilibrium position. That means x should be equal to 0. So what do I get for part B? I'll substitute x equal to 0 in this equation. So this is going to give me 0 is equal to 5 sine 20t plus pi by 3. That means sine 20t plus pi by 3 is 0. That means 20t plus pi by 3 should be equal to what? This should be equal to what? This should be equal to 0. If I take it as 0, think what time will come out to be. It will come out to be negative, which is not possible. Alright, so I'm going to take the next value. What is the next value? It's pi. It's pi. So from here, t will be equal to what? T will be equal to 1/20 multiplied by pi minus pi by 3 would be 2 pi by 3. So that gives me pi upon 32nd. Is that clear? That is how we can solve this question using equations. It's pretty straightforward. Alright, but we want to solve it using phasors, which would make it much simpler. How it is going to make it much simpler? Let's draw the phasor diagram. Okay, what is the initial phase of the particle? Pi by 3 is the initial phase of the particle. So I'm going to say that this is the initial position of the particle. At t is equal to 0, the particle would be over here. Is that correct? The initial phase is pi by 3. Okay, now the question is, the first part of the question is what? First come to rest. Where does the particle come to rest? At the extreme position. Where is the first extreme position? Right here. This is the extreme position. Is that correct? If this is the extreme position, how much angle has this particle rotated? Pi by 2 minus pi by 3, and how much is that? Pi by 6. And what is the angular frequency of the particle? The angular frequency of the particle is 20 per second. The angular frequency of the particle is 20 per second. Is that correct? Okay, so what is the phase change, or how much phase has it rotated? It has rotated by a phase pi by 6. Is that correct? Yeah. Pi by 2 minus pi by 3. Yes, pi by 6. This particle is over here. Now this particle goes here. How much angle has it rotated? This is already 60 degree. This whole angle is how much? 90 degree. So how much has it rotated? It has rotated 30 degree, pi by 6. Is that clear? And the angular frequency is 20 per second. What does that mean? It means that is the phase velocity. That is rate of change of the phase. So can I say what will be the time taken? The time taken would be equal to the phase rotated divided by the phase velocity. That's it. That's it. Is that clear? Any problem? So you only have to see what is the angle rotated, what is the phase rotated. That's it. And you already know what is the phase velocity. The phase velocity is a constant. So simply to find time, you will divide both the things. That's it. Is that clear? Okay, what is the second part of the question? The second part of the question is, when does it first come to rest? Okay, so where on this phasor diagram will it come to rest? Okay, what is this next part? Zero acceleration. Where the particle is going to have zero acceleration? At the mean position. Where on this phasor diagram should I mark the mean position? If I mark it here, I cannot go back in time. Alright, I cannot go back in time. The phase is rotating like this. Okay, so when I will the particle be at the mean position? Here. Okay, so how much angle has the particle rotated? From here, how much angle has it rotated? The phase. Pi by 2 plus pi by 6. What is the phase rotated from here? Pi by 6 plus pi by 2. Okay, how much is that? Pi by 2 plus pi by 6. This is the phase rotated. And what is the time? What is the phase velocity? Just divide it by that. So this you are going to get as, so this will become 2 pi by 3, so pi by 30 second. Is that clear? Doesn't this make it much simpler than solving equations? Okay, what is the third part of the question? First have maximum speed. Where on this phasor will it have maximum speed? At the mean position. Where does the SHM have the maximum speed? At the mean position. Where is the mean position? Here is the mean position. So you'll get the same answer. Is that correct? Any problem? Good. Write the next question. X is equal to 2 cos 50 pi t 2 cos 50 pi t plus tan inverse 0.75. X is equal to 2 cos 50 pi t plus tan inverse 0.75. Alright, that is the equation of an SHM. Alright, the first part of the question is, or the question is, when does the particle, part A, when does the particle, part A, first come to rest? First come to rest. Has part B has maximum magnitude of acceleration. Has maximum magnitude of acceleration. Part C comes to rest for the second time. Comes to rest for the second time. Alright, now you may try this. How much is tan inverse of 0.75? 37 degree. Alright, 37 degree in radian, you can approximately write it as pi by 5. Correct? Pi by 5 is 36 degree. So 37 degree you can approximately write it as pi by 5 in radians. Yeah. This is the equation. 2 cos 50 pi t plus, now you can write it as pi by 5. The first part is, tell me in terms of radians. What is the angle rotated? 3 pi by 3 pi by 10 is the angle rotated for the first part. Yeah. First come to rest. Where will it come to rest? At the extreme position. Okay, so that is pi by 2 minus pi by 5. Pi by 2 minus pi by 5. All right. Okay. Now the problem here is, understand this. The problem here is, this is in terms of cos. This is in terms of cos. So the sine of the phase angle that used to give you the position. But here the cos of the phase angle is going to give you the position. In this case, x is equal to 2 cos 50 pi t plus pi, pi by 5. Alright, so the cos of the phase angle is going to give you the position. Okay, so you can do two things. One you can do is, you can interchange the x and y axis. That is, assume that the vertical projection is going to give you velocity and the horizontal projection is going to give you the displacement. Alright, that is going to give you the displacement. Alright, but what will happen, it will amount to confusion. Okay, it may amount to confusion because you are used to of taking the vertical axis as the position. Okay, so it is better to convert this equation into sine. Alright, and then solve it, and that will make it much simpler. Okay, so I can write this equation as x is equal to 2 sine of 50 pi t plus pi by 2 plus pi by 5. Is that correct? I can write cos as sine 90 plus theta. Sine sine 90 plus theta is equal to cos theta. Yeah, sine 90 plus theta is equal to cos theta. Sine is positive in the second quadrant. Sine 90 plus theta will be equal to cos theta. I don't know the answer. Okay, let's see. Same आएगा. The phase angle rotated would come out to be the same. Alright, in this question it does not make a difference. Listen to me again. In this question it does not make a difference if you plotted x-axis and you still took the position as the y-axis. Alright, you still took the position as the y-axis and you use this equation cos. The answer in this question is not going to differ because the angle rotated you'll still get the same. Does not matter. Alright, but I told you as a general case. Why? Because you could have, or in the question you would have to find the position or the velocity. In that case you'll face confusion. That is why if you're using phasors, it is a better idea to always convert it to sine. That way you'll be familiar with what you need to do. Alright, what is the initial phase of the particle? Pi by 2 plus pi by 5. So I'll start from here because I've assumed sine. So I'll start from here, I go pi by 2. So this angle would be pi by 5. Alright, so the initial phase is pi by 2 plus pi by 5. Okay, then what is the question? The first part of first come to rest. All right, where would it first come to rest? At the extreme position. Where is the extreme position? Here is the extreme position. So how much is this angle? This angle is pi minus pi by 5. So the time taken would be pi minus pi by 5. That is the phase rotated, or that is the phase. Alright, the change in phase. And what is the angular frequency? The angular frequency is 50 pi. So you need to divide it by 50 pi. So you are going to get 4 pi by 5 divided by 50 pi. So this disappears, and what do you have? You have 2 and you have 25. So you have 2 upon 125 second. Huh? First come to rest at the extreme position. Absolutely. Where would it come to rest? At the extreme position. So this is the extreme position. Is that clear to everyone? Alright, what is part B? What is part B? First have maximum acceleration. When does it have the maximum acceleration? At the extreme position. Again, this is the extreme position, so the time should be the same. So this should be 2 upon 125 second again. Alright, what is the third part of the question? Come to rest for the second time. Alright, so after how much time would it come to rest? First time it is going to come to rest over here. Second time it is going to come to rest at what point? At this point. No, after half time period. Here is again, this is again an extreme position, so particle will again come to rest. Is that correct? So how much how much time will it come to rest for the second time? That means first going through this angle it will come to rest, and then going through half the cycle it is going to come to rest again. Is that clear? Okay, so how much is the phase angle rotated? The phase angle rotated is 2 pi minus pi by 5. The phase angle rotated is 2 pi minus pi by 5, and that should be divided by 50 pi, and that should be your answer. Is that clear to everyone? Any problem? First part, which part do you have confusion in? So what is the phase angle? At t is equal to 0, what will be the phase angle? Pi by 2 plus pi by 5. So that angle I have to take from the x-axis. So this is pi by 2 plus pi by 5. That is the complete angle. Correct? No, I'm using the same thing which we have been using. Alright, x-axis, y-axis. The vertical projection is going to give me the vertical component is going to give me the position. The horizontal component will give me the velocity. I'm sticking to that convention. Is that clear? हाँ? किए तो ये तो रहा pi by 2. किस में बोलो? फर्स्ट पार्ट में. ऑलराइट गाइस, वन सेकंड. हाँ बताओ. क्यों करेंगे? पार्टिकल इनिशियली कहां पे था? पार्टिकल इनिशियली यहां पे था. पार्टिकल पहली बार रेस्ट पे कब आएगा? जब यहां पे आएगा. तो एंगल रोटेट कितना किया है? यहां से यहां तक आया है. So what is the phase rotated? Only this is the phase rotated. How much is that? Pi minus pi by 5. That's it. Is that clear? थर्ड पार्ट में बताइए क्या कंफ्यूजन है? एक साइकिल कहां से कहां कंप्लीट होता है? अगर एक्स एक्सिस पे इस पॉइंट से शुरू करेंगे तब तो वापस यहां पे आएगा तो कंप्लीट होगा. बट शुरू कहां से हुआ है साइकिल? साइकिल शुरू तो यहां से हुआ है ना. तो जब ये वापस यहां पे आएगा तब तो एक साइकिल कंप्लीट कहेंगे. करेक्ट? Alright, is this clear to everyone? Any problem? Alright, now let's complicate matters a bit. Write down the next question. Two particles. Two particles execute SHM. Two particles execute SHM with same frequency, same amplitude, and along the same straight line. Two particles execute SHM of with same frequency, same amplitude, and along the same straight line. They cross each other at a point. They cross each other at a point midway between mean and extreme position. They cross each other at a point midway between mean and extreme position. Find the phase difference. Find the phase difference. Is the question clear? Alright, so now we have two particles which are executing SHM about the same, with the same frequency, same amplitude, same mean position, and along the same straight line. Alright, okay, that is along this line. What is the question? Say this is the amplitude. So they cross each other. That is, one particle will go like this, one particle will go like this. That is the only way they can cross each other, because at this point, at the same position, they are going to have same speed. So if they're going into this in the same direction, can they cross each other? They cannot. Is that correct? At the same position, they're going to have the same speed. Correct? If they're going in the same direction, can they cross each other? So the thing which is given in the question is they cross each other. How would they cross each other? If they're moving in the opposite direction. So they meet here at a by 2, half the extreme position. They meet over here and they are crossing each other at this point. Okay, now the question is, what is the phase difference? Clearly there is a phase difference between the particles because they are in different points in the cycle. Alright, now we have to find out the phase difference. Okay, one way to find the phase difference is, you can use equations. Alright, and let's see how we can solve this using equations. Okay, so first of all, let's assume that the first particle is the difference pi. No, pi is not the correct answer. Why did you think it's pi? Not necessarily. No. See, first let's assume the equation of the first one as a sine omega t. Okay, and let's assume the equation for the second one as a sine omega t plus delta. So what is the phase difference between these two particles? It's delta, and that is what we need to find out. Okay, so first of all, what do we know? We know that at time t, what is the position of the particles? It's same. At time t, what is the position of the particles? It's same. That means what? That means a sine omega t should be equal to a sine omega t plus delta. That is equation number 1. What else do we know? What about the velocity? The velocity, only the magnitude would be same, but the direction would be opposite. That means what? What will be the velocity of particle 1? The particle 1 will have a velocity of a omega cos omega t, and this should be negative of a omega cos omega t plus delta. Is that correct? Okay, I think you don't yet know what the general solutions. You have not studied general solutions. Okay, if you have not studied general solutions, it's all right. But when you study general solutions, if two sine terms are equal, that means this should be equal to 2n pi plus minus of this angle. Okay, there is a solution. Basically, if this is equal, there is a solution. Alright, from here you'll get one equation, and from here you'll also get another equation, and solving those two equations you'll be able to find out what is the magnitude of delta. Is that correct? That is one way to solve it, and for people who already know trigonometric general solutions to trigonometric equations, you can solve it this way. Okay, but you see that it becomes slightly complicated to solve two equations, two variables, and that too sinusoidal equations or trigonometric equations. Is that clear? Okay, but this question we can solve it using phasors in a much simpler way. Okay, the thing is, can we correctly plot the particles on the phasor diagram? That's it. That's all you need to do. Now the particles have the same mean position, same frequency, okay, same amplitude. That means the size of the circle would be same for both of them. Their initial position would be the same, not the initial position, but the mean position would be the same. Okay, now they have the same frequency. What does that mean? They are going to rotate with the same angular velocity, or I can say with the same phase velocity. Is that correct? Okay, what is the position of the particles? The position of the particles is a by 2. The position of the particles is a by 2. Is that correct? Where is a by 2? Here is a by 2. Okay, so the particle, let's say the first particle is over here. Okay, the first particle is at a by 2. Okay, now the question is, where should I plot the second particle? Where should I plot the second particle? I should plot the second particle over here. Why should I plot the second particle over here? Because the position is the same. The vertical projection for both the particles would be the same. But what about the velocity? The velocity is the horizontal projection of this larger circle. Velocity is the horizontal projection so this should be the velocity of the particles. Okay, what do we see? What do we see over here? The magnitude is the same, but for this particle, what is the direction of velocity? It's positive. This thing comes out to be positive. And for this particle, what is the direction of the particle? It's negative. That means they are crossing each other. They're moving in the opposite direction. So if I plot one particle over here, I should plot the other particle right over here. Is that correct? Any problem? Okay, now what is the phase difference between the two? This angle is the phase difference between the two. Is that correct? That is the phase difference between the two. Okay, so how much is this angle? This is a by 2 and this is a. So clearly this angle is how much? It's pi by 6. Correct? Cos theta is equal to a by 2 by a. So that angle is pi by 6. Sorry, pi by 3. Cos theta is equal to half. This angle is theta. Okay, so cos theta is equal to half. That means theta is pi by 3. So this angle should also be pi by 3. So what is the phase difference between the particles? 2 pi by 3. That's it. Is that clear? All you need to do is plot the particles, the position of the particles correctly, and then you'll be fine. Any problem? Alright, write the next question. Two particles execute SHM. Two particles execute SHM with same amplitude, same time period, same mean position, and along the same straight line. Amplitude is equal to 20 centimeter. Amplitude is equal to 20 centimeter. The maximum distance between the particles is 20 centimeter. The maximum distance between the particles is 20 centimeter. What is the phase difference? What is the phase difference? Sorry? Pi. How? The maximum distance between them is, nobody is telling you at t is equal to 0 they have the maximum distance between them. Nobody is telling you that. Yeah, the maximum separation between them is 20 centimeter. That can happen at any time. You don't know. Try. Mm-hmm. What's your logic? One particle is as at its mean position, the other particle is at its extreme position. Why do you think will that be the maximum separation? At an instant they can be there, but why do you think that will be the maximum separation? All right, the amplitude is a, that is the maximum separation between the particles. But why do you think that it will happen, the maximum separation will happen when one particle is at its origin and the other particle is at its extreme? That can also happen, absolutely. Can't this happen, that the maximum separation is when this particle is over here and this particle is over here, a by 2, a by 2? This may also happen. Is the answer? Why are you guessing? Alright, try solving it. Huh? Pi by 3. Why pi by 3? Maximum velocity a by 2 पे क्यों? Why is that? So that is just an example. Arey baba, that is just an example. ये भी तो a हो सकता है. अब कहाँ दोनों का velocity same होगा? It can happen anywhere. You don't know. You don't know that for sure. Why? Why? First of all, you need to think, when will there be maximum separation between the particles? Why? Explain that. Hmm. 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 Correct. ठीक है, agreed. Absolutely. Alright. Now the thing is, the particles will have this maximum separation when the velocity of the particles is the same. Can you digest that? Yes, no. Okay, we saw this in mechanics, or we saw this in the spring problem. Okay, when was the maximum compression? This particle was moving at v1, this particle was moving at v2. If particles are moving with variable velocity, when will there be maximum compression or maximum elongation? When the velocity becomes equal, both in magnitude and in direction. Is that correct? So you are going to have maximum separation when the particles are moving with the same velocity, meaning the magnitude as well as the direction. That is when you are going to have the maximum separation between the particles. Is that correct? Okay, now you need to plot that and need to find that out, when will the particle will have the same velocity. then the both the particles will have zero velocity at the extreme position. But do they simultaneously come to rest? Do they simultaneously come to rest? No. All right, so take some time, draw the phasor, try this solving this using phasor, and think. Plot it on the phasor and tell me. इतना छोटा तो हमको टेलीस्कोप चाहिए होगा, थोड़ा बड़ा बनाना. Is that same velo कहाँ पे? Correct. Yes, that is correct. Yes. Sixty, 60, 120. आंसर वो सही बोला, आंसर would be pi by 3. 3. 'देखो, suppose the first particle is over here, the first particle is over here, and the second particle is over here. This is the phase difference between the particles. Alright, this is the phase difference between the particles. Let's say initially this is the situation. Okay, this is the phase difference between the particles. Now both of them have the same angular frequency. That means what? They're going to rotate together. That means they're going to rotate like this. The separation, the angular separation between these two lines is not going to change. Okay, and then I need to see where does the velocity becomes equal, both in magnitude and direction. When will that happen? When the horizontal projection becomes the same. Is that correct? When the horizontal projection of the particles becomes the same, then the particle will have the same velocity. Is that clear? So when is that going to happen? Right now, is the horizontal projection same? Right now, is the horizontal projection same? No, they're in opposite directions. When the particle is like this, alright, iska horizontal projection positive, iska horizontal projection negative, chalega? Nahi chalega. It has to be equal in magnitude as well as direction. Okay, so when is that going to happen? When this particle reaches this point, isn't it? So this will also have the same projection in the negative side. This will have also have the same projection in the negative side. That means what? Both the particles should have this projection. Both the particles should have this projection. So one particle should be over here, the other particle should be over here. Is that correct? Okay, now join these two. Is that correct? Okay, so this again is your phase difference. Okay, and if this angle is theta, I can also say this angle is also theta. Okay, why? Because of symmetry. Because of symmetry, this horizontal projection is going to be same if these two angles are same, because the amplitude is the same for both of them. Okay, what else is supplied to us? The maximum distance between them. The maximum distance, how do I find the maximum distance? This is the position of the particle, and this is the position of the particle. From symmetry, can I say that the position of the particle would be, the magnitude of the displacement would be the same? It's just that they're in the opposite direction. That means what? This should also be a by 2, and this length should also be a by 2. I can say that with symmetry. Is that correct? Exactly a by 2. Why not? The separation between two them is how much? A. Now this is, iska position ye hai, iska position ye hai. What should be this distance? This should be A. Now this angle has to be same. To have the same horizontal projection, this angle has to be same. That means what? This is a symmetric condition. A को आधा आधा बांटेगा तो क्या मिलेगा? If this distance is A by A, this distance and this distance should be equal. So this should be half of that. So this should be A by 2 and this should be A by 2. Is that clear? Any problem? Okay, so basically if this is A by 2, this is A, what should this angle be? This angle should be equal to pi by 6. So this angle is also pi by 6. So what should be the phase difference? The phase difference would be pi by 3. Is that clear? Any problem? Alright, and do remember this concept. When there is the when is there the maximum separation between the particles? Any problem? Good. Next question. Exact same line जो पहले वाले question में था. ठीक है, two particles executing SHM, same frequency, amplitude, mean position and along the same straight line. Okay, now write the question. When P and Q, those are the two particles, when P and Q are on opposite sides of O, which is the mean position, P and Q are on opposite sides of O at the same distance, they have same speed 1.2 meter per second. They have same speed 1.2 meter per second in the same direction. They have same speed in the same direction. Alright? When their displacements are the same, they have same speed 1.6 meter per second. They have same speed 1.6 meter per second in opposite direction. (1.6 meter per second in opposite direction). Find the maximum velocity of either particle. Find the maximum velocity of either particle. Yeah. When the displacement is same, displacement from which point do we consider? From the mean position. If the displacement is same from the mean position, they have velocities which are opposite in direction and has a magnitude of 1.6 meter per second. Displacement same means displacement we are taking from the mean position. So basically when they are at the same position. from the mean position. Hmm. At the same distance from O. Yeah. P and Q are the particles, O is the origin. Is the question clear to everyone? I see there is some confusion. Not clear. Okay. So it says when they are at the same distance on either side of O, they have the same velocity. Alright? They have the same speed going in the same direction. That means this is the origin. So this is P and this is Q. So they are this distance and this distance is same. But it is on opposite sides. And they have this velocity. Same velocity of how much? 1.2 meter per second and going in the same direction. Alright? Okay. Then it says when their position is the same or when the displacement is the same, that means they're at the same position. Okay, so I don't know where, but let's say those two particles are नहीं उधर तो नहीं हो सकता हाँ. Both P and Q are at this position. Now they have a velocity which is same but opposite in direction. So one particle may be going like this, the other particle may be going like this. Is that clear? That is the question. Hmm. Okay, they have the same velocity. Yeah. And they have this. ये कैसे हो गया? ये सेम पोजीशन कैसे हुआ? हाउ इज दिस द सेम पोजीशन? इसका पोजीशन यहाँ पे है, इसका पोजीशन यहाँ पे है, तो सेम पोजीशन कैसे हुआ? They should be in the same position. Correct. Yes, yes, you are right. You are right. Yes, you are right. Yes. करेक्ट करेक्ट बिल्कुल सही. चल अब सॉल्व कर. See, in the first case, the velocity is the same. That means what should be the same? The horizontal projection. That should be the same. In the second case, the position is the same. So what should be the same? The vertical projection should be same. Do you get that? And same not just in magnitude but in direction also. The vertical projection should be both positive or both negative. The horizontal position should be both positive or both negative. Is that correct? Alright, so how do you get that? Simple. First case. What is same? The velocity is the same. So horizontal projection has to be is the same. How will I have horizontal projection same? Let's say this is the horizontal projection. So where can be the particles? One particle can be here and the other particle can be here. That is the only way I can have the same horizontal projection. Okay. And this I'm drawing it as a omega because I have to deal with velocities. So this circle I have made is with a radius of a omega. What is a omega? The maximum velocity. And basically what I have to find out. Is that correct? Okay. So let's say this angle is theta, so this angle will also be theta. You get that? Because of symmetry, they are the same hypotenuse and they need to have the same horizontal projection. How is that possible if these two angles are the same? Is that correct? Okay. Now what has been given to you? What is the velocity? 1.2 meter per second. Where should I plot that velocity? This horizontal component then is equal to 1.2 meter per second. Is that correct? Any problem? Yes, no? Is that clear? What is the horizontal projection? That is the velocity of the particles. So this horizontal projection is the velocity of the particles. How much is that given in the question? It's 1.2 meter per second. So this distance is how much? It's 1.2 meter per second. Any problem? No. Good. Now what is the next part? What is the next part? When they have the same position. When will they have the same position? When they have the same vertical component. Okay, how can they have the same vertical component? This is how they can have the same vertical component. Okay, so where should be the positions of the particle? One particle should be here, one particle should be here. There is no other way. Alright, so this is again a omega. Now can I again say that the angle between them should be theta and theta? Why? Same what? Same angular frequency. Same angular frequency. So the phase difference between them is not going to change. They're going to rotate with the same phase velocity. So the phase difference is not going to change. Okay, so this angle is again going to be 2 theta. And this angle will be theta and this angle will also be theta. Again symmetry. You get that? Any problem? Now, what is the velocity given to you? 1.6 meter per second. Where on this one is 1.6 meter per second? No, it's the velocity. It is this one. It is the horizontal projection which is the velocity. Same as this. Same as this. It is the horizontal projection which is the velocity. So this projection is 1.6 meter per second. Not. This is the position. Is that clear to everyone? Any problem? Okay, so from this triangle, can I say that cos theta is equal to how much? Is equal to 1.2 upon a omega. And from this triangle, can I say sin theta is equal to 1.6 upon a omega. What do I need to find out? What is the question? What is it that I have to find out? What is maximum velocity? It's a omega. So this is one variable, this is the other variable. How do I solve this? Square and add. Simply square and add. So if you square and add, you are going to get 1.2 square upon a omega square plus 1.6 square upon a omega square, and this should be equal to 1. Sin square theta plus cos square theta should be equal to 1. So from here I'm going to get a omega is going to be the under root of 1.2 square plus 1.6 square. How much is this? 2 meter per second. Do you see the Pythagoras triplet over here? 3, 4, 5. So 3, it is multiplied by 0.4. 4 is multiplied by 0.4. So 5 should be multiplied by 0.4. So that is 2 meter per second. This should be the maximum velocity. Because the phase difference is constant. These are two lines. If both my fingers are moving with the same angular velocity, can the angle between my fingers change? So this is, if this is 2 theta, the phase difference, this should also be 2 theta. And since you have the same vertical component, these two angles have to be the same. Is that clear? Displacement from the mean position. When they are talking about displacement in SHM, what do they mean? Displacement from the mean position. That means what? The position of the particle. That's it. Alright, is that clear to everyone? Okay, go home, try using solving this using equations, trigonometric equations. Then you'll know why phasor is such an excellent method. Alright, can I wrap this off? So we have talked about the equation of the SHM, we have talked about the different parameters of SHM. Alright, let's also talk about the energy involved. Alright, basically energy conservation in SHM. Alright, so let's take a simple example. You know the spring mass system is performs in SHM. You know that the spring mass system performs in SHM. Alright, okay. So if you displace it by a certain distance, let's say at position x, so this is the mean position of the particle, let's say it is executing SHM. So at position x it has a velocity v. Let's assume that at a general position x it has a general velocity v. Okay, now the equation can be given as a sine omega t plus delta. That is the particle position of the particle. Okay, the velocity will then be given as a omega cos omega t plus delta. Is that correct? Okay, now what we can do over here is, what is the kinetic energy of the particle at an instant? The kinetic energy of the particle would be half mv square. So that is equal to half into m into a square omega square cos square omega t plus delta. Is that correct? Okay, what will be the potential energy of the system? The potential energy mgh mgx किधर किधर ध्यान है भाई? Okay, the potential energy of the system will be half kx square, so that will be equal to half into k into x square is a square sine square omega t plus delta. Okay, now we can also find out what is the relationship between omega and k. How do we find that out? What will be the equation, the force equation for SHM? It will be F is equal to minus kx. So can I say A is equal to minus k by m into x? And if you remember, we substituted omega square for k by m. Is that correct? Why we were deriving the equation for SHM? We substituted omega square for k by m. Okay, that means what? K should be equal to m into omega square. And I can substitute that value over here. So this will become half, and in place of k I'm going to write m omega square a square sine square omega t plus delta. Is that correct? Any problem? Excuse me. So what will be the total mechanical energy of the system? The total mechanical energy of the system would be k plus u. Is that correct? And what will be k plus u? Add these two quantities, what do you get? This is common, so you'll get cos square something plus sine square something, that means 1. So the total mechanical energy of the system would be half m omega square a square. Alright, which of those terms is a variable? None. Alright, for an SHM, omega will be constant. Right, for an SHM, what is the total energy of the system? It's constant. That means the mechanical energy of the system is conserved. Okay, so when the particle is at its extreme position, all the mechanical energy is in the form of potential energy. Okay, so if all the energy is in terms of potential energy, what is the potential energy of the particle at the extreme position? That will be half k, and what is x? X will be equal to a. So that will be equal to half k into a square, and basically what is k? M omega square. So at the extreme position, the entire mechanical energy is in form of potential energy. At the mean position, what is the potential energy? 0. So the entire energy is in form of kinetic energy. What is the velocity of the particle at the mean position? What is the velocity of the particle at the mean position? Maximum. And how much is maximum velocity? A omega. Excellent. A omega. So what is the kinetic energy? Kinetic energy is half m v square. Is that clear? So this is the total mechanical energy. At the extreme position, all the mechanical energy is in form of potential energy. At the at the extreme position. At the mean position, all the mechanical energy is in the form of kinetic energy. Is that clear? This conservation of mechanical energy is happening if there is no external force. Alright, SHM can take place even if there is an external force acting. In that case, we cannot conserve mechanical energy. Alright, so mechanical energy is conserved for an SHM, and mark it with a star or an asterisk, that if no external forces are acting. Correct? If we consider external forces, then mechanical energy will not be conserved, but for sure work energy theorem will still work. Is that correct? Alright. Okay, now we can go and start finding the time periods of SHM. Alright, so a major portion in this chapter would have the same question. What is that question? Prove that following phenomena or following situation, the particle is executing an SHM, and if yes, find the time period. Alright, so for a very large portion of this chapter, this same question is going to be repeated again and again for different mechanical systems. Alright, so we'll learn how to find first of all, prove how if a motion is SHM, and also find the time period of that SHM. Alright, the way to do it is, and you may note this down. Write it. Finding the time period of an SHM. Finding the time period of an SHM. Step 1. Find the equilibrium position. What do you mean by the equilibrium position? The net force 0, nothing else. The equilibrium position means the net force should be 0. So that is the first thing you need to find it. Okay. Step 2. Displace the particle from the mean position. Displace the particle from the mean position. Step 3. Find the net restoring force on the particle. Step 3. Find the net restoring force on the particle. Find the net restoring force on the particle. Step 4. If F is proportional to minus x, it is an SHM. So you find the net force, and you find that the net force is equal to or is proportional to the displacement and opposite to the displacement, that means you have proved it that it is an SHM. Alright, once you have done that, what you need to do is step 5, find acceleration and compare it with A is equal to minus omega square x. Find the acceleration and compare it to A is equal to minus omega square x. Alright, so we find the acceleration. What is the coefficient of x? That will be omega square. Alright, how did this come? The same thing we did. So F is equal to minus kx, so A is equal to minus k by m into x, and this thing we substituted with omega square, and it came out to be the angular frequency. Alright, so compare this equation with minus omega square x. So you can find omega. Once you have found omega, the time period would be 2 pi by omega. And that is what we are going to follow in all mechanical systems. Alright, later on we'll find better methods of finding the time period. We'll look at energy method and some other things. But for now, we're going to stick to the basics. Is that clear? Okay, so let's find out the time period of the simplest thing you can get, and that is a spring mass system. So we need to find the time period of a spring mass system. And for this first situation, the spring mass is placed on a horizontal frictionless surface. Okay. Now, what is the first step? Find the equilibrium position. Alright, what is the equilibrium position? So difficult to find that out. Where is the equilibrium position? It's its natural length. Alright. When the spring is at its natural length, naturally the particle is at with zero force and it is at equilibrium. Alright, so this is the equilibrium position. Okay, what is step 2? Displace the particle by a distance x. Displace the particle. Alright, so I have displaced the particle. Let's say I have displaced the particle by a distance x. Alright, now at this position you displace it, and at this position you have to find out all the forces acting on the particle. Okay, so what are all the forces acting on the particle? First of all, there is a spring force kx, and then there is mg, and then there is normal. You have to find out all the forces. You have to look at all the forces. You need to find out the net force acting on the particle. Okay, it's obvious that mg and n are balanced. Mg and n are balanced. So what is the net force on the particle? It's kx. And what is the direction of that net force? Is it opposite to x? Absolutely, it is opposite to x. So I can write the force as minus kx. This k tells me it's proportional to x, and this minus sign tells me it is opposite to x. Alright, so what does this mean? Is this an SHM? Is this motion an SHM? Absolutely, it is an SHM. Alright, now what we need to do is we need to find out the time period. Okay, if we want to find out the time period, we'll find the acceleration. The acceleration would be minus k by m into x. And we compare it with what equation? We compare it with minus omega square x. So what is omega square? Omega square is k by m. So what is omega? Omega is under root k by m. So what is the time period of the motion of this particle? That 2 pi by omega, that is 2 pi under root of m by k. And that is a result you absolutely must remember. Alright, root over of 2 pi into root over of under root of m by k. Is that clear? Any problem? You understand the steps followed? Excellent. Now what I want you to do is, I have suspended this particle. I have suspended this particle, and then I displace it slightly and leave it. Okay, you'll see vertical oscillations of the particle. Alright, the question is the same. Find the time period of SHM. First of all, prove that it is an SHM, and then you need to find out the time period of SHM. displacement always has to be from the mean position. F is equal to minus kx, x always has to be from the mean position. सेम आया, डिफरेंस क्या है? Absolutely, absolutely. All right. The first step is to find the equilibrium position. Obviously, the natural length of the spring will not be the equilibrium position. It will come down. Okay. So let's say it comes down by a distance x naught. It comes down by a distance x naught. So what are the forces acting? Kx naught and mg. This is the equilibrium position. So at the equilibrium position, can I write kx naught is equal to mg? Okay. ले लिए ना डायरेक्शन, तभी तो this equal to this. All right, is that clear? Okay, now from this is the equilibrium position, so all the displacements have to be measured from where? From the equilibrium position. So from this equilibrium position, I displace it further. I displace it further by a distance x. I displace it further by a distance x. Now at this position, I need to find out the net force. Alright, so what are the forces acting? Mg is acting. What is the spring force over here? Excellent. The force is kx plus x naught, because the elongation of the spring now is x plus x naught. Okay, so what should I write as the net force? Again, what is the direction of displacement? It's downward, so by default I'll take the downward direction as positive. So the force which is acting in the downward direction, I'll take it as positive. The force acting in the upward direction, I'll take it as negative. So I'm going to write the net restoring force will be equal to minus kx plus x naught plus mg. Is that correct? So this will be F is equal to minus k minus kx naught plus mg. This cancels out from the equilibrium position equation. So what do I get? I get F is equal to minus kx. Again, the net restoring force is minus kx. So the time period will still come out to be what? 2 pi under root of m by k. Is that correct? Any problem? Excellent. Now what you do is, you keep the spring mass system in an elevator and now send the elevator upward with an acceleration a. Alright, now find the time period, or first of all prove that it is an SHM. If yes, find the time period. करके देखो, करके देखो. एलिवेटर ए एक्सेलरेशन से जा रहा है, ठीक है. तो SHM कैसे होता है? फर्स्ट ऑफ ऑल व्हाट यू डू इज यू डिस्प्लेस इट फ्रॉम द इक्विलिब्रियम पोजीशन. and then it will start executing SHM. ठीक है. अगर इसको रेस्ट से ये एक्सेलरेशन से डालेंगे ऊपर, then you'll have to find the amplitude and other things. ठीक है, that will come later. नहीं, then that will be in the non-inertial frame. It's the pseudo force applying the force. In the inertial frame, it's the inertia of the particle. A constant है, हाँ, A constant है. सेम होगा. So what is the difference between this one and this one? नहीं, SHM के ऊपर क्या difference पड़ रहा है? Correct. The equilibrium position will get shifted. Okay. So if this is in an elevator, in an elevator which is going up at an acceleration of a, first of all what you need to find out is the equilibrium position. Okay, suppose this was the natural length of the spring. The block is elongated, or the spring is elongated by a distance x naught. Okay, so what are the forces acting on the particle? Mg and the pseudo force Ma, and the force upwards is kx naught. So in the equilibrium position, kx naught should be equal to mg plus ma. Is that correct? Any problem? Okay. Now from this equilibrium position, I can rub this off. We have to send it further down by a distance x. You can displace it either way. You can displace it upward, you can displace it downward. It won't make a difference. Okay, so what you do is you displace the particle by a distance x from the equilibrium position. Okay, now what are the forces acting on the particle? Mg is acting, Ma is also acting, and what is the upward force? The upward force would be equal to kx plus x naught. Alright, so what will be the net force? The net force will be equal to mg plus ma, that is positive, minus kx plus x naught. From this will cancel out. You'll get F is equal to minus kx. You'll find the time period the same. Any problem? Correct. Time period of a spring mass system only depends upon M and K. Alright? The time period of an SHM or spring mass system only will depend on M and K. Is that correct? Okay. A constant force F is applied on the particle. A constant force F is applied on the particle. Initially the particle is at the natural length of the spring. A constant force F is applied on the particle. You need to find out if this is an SHM or not. If yes, find the time period and also find the amplitude. Alright, time period and amplitude. is the F net F minus kx. X has to be from where? X has to be measured from where? From the equilibrium position. Is this the equilibrium position? Correct. तो टाइम पीरियड क्या आएगा? आना चाहिए, बट करके लाओ, दिखाओ, बोलने से थोड़ी होगा. वो तो हम बोल ही दिए स्टेटमेंट. कुछ भी कर लो स्प्रिंग मास सिस्टम का, टाइम पीरियड ओनली डिपेंड्स ऑन एम एन के. बट कैन यू प्रूव इट? Done. And you also need to find out the amplitude. एक्सेलरेशन के टर्म्स में कैसे तुम बता सकते हो आंसर? इज ए गिवन टू यू? इज ए कांस्टेंट? Alright, first of all, could you find out the time period of SHM? Okay, so the spring will be compressed. Let's say the spring is compressed by x naught, and this is the equilibrium position. Okay, so what can I write about the equilibrium position? Kx naught will be equal to F. Alright, now if this is the equilibrium position, I need to displace it by a distance x. So I'll further displace it by a distance x. Now what are the forces acting? Mg normal will cancel out each other, no problem. What is this? This is kx plus x naught. And what is this? This is F. Constant force F is acting. Alright. So what will be the net force on the particle? The net force on the particle would be, and I have to take F as positive because that is in the direction of displacement, minus kx plus x naught. So x naught, so kx and kx naught and F cancel out. So what do you get? You get the net force is equal to minus kx. So naturally the time period will come out to be 2 pi under root of m by k. Is that correct? But the question is, you need to find the amplitude also. How do you find the amplitude? V0, yes. So sorry, एनर्जी कंजर्व होगा इस केस में. एक्सटर्नल फोर्स भी है, तो क्या करना पड़ेगा? वर्क एनर्जी थ्योरम वी हैव टू अप्लाई. वर्क एनर्जी थ्योरम. ऑलराइट, so this is the natural length of the spring. Where would be the amplitude, or where basically when will the particle come When the particle comes to rest, that will be the maximum displacement in this direction. Alright, let's say the particle comes to rest at x. The particle comes to rest when the compression of the spring is x. Alright, will the particle come to rest over here at the mean position? It will have the maximum velocity at the mean position. Alright, we'll talk about that. Anyway, first of all, let's say the particle comes to rest when the compression of the spring is x. Now what we can do is we can apply work energy theorem. So work done by the external force, what is the work done by the external force? Fx. So this should be equal to the change in potential energy. What is the change in potential energy? Half kx square. What is the change in kinetic energy? 0. It was at rest over here, it is at rest over here. So the change in kinetic energy is 0. So from here, not cancelling out, but because x cannot be 0, x cannot equal to 0 cannot be my answer. So I can cancel out x, and so x will come out to be 2f by k. So this will stop after traveling a distance 2f by k. Is that correct? Okay. Now tell me, from where is the amplitude calculated? From the mean position. Where is the mean position? The mean position is at x naught is equal to f by k. Is that midway? So this would be the mean position of the particle. So this is going to be f by k. And what will be the amplitude? The amplitude will be f by k. Is that clear? The amplitude has to be calculated from here. So this is the maximum displacement of the particle from the mean position. And how much is this? This is f by k. So the particle is going to perform SHM about this line and with an amplitude f by k. We'll start from here, come here. We'll go on like this. Is that clear? Any problem? Okay, but the moral of the story is, for a spring mass system, in any situation, the time period would be 2 pi under root of m by k. Okay? Next, time period of a simple pendulum. You know what is a simple pendulum? I hope you do. जिसे hypnotize करते हैं. तो बहुत simple होता है. अभी देखिए कितना simple आता है. Alright. ईशान पता है ना? Simple pendulum. कितना simple होता है? Alright, so basically a simple pendulum is a mass suspended by a string, okay, and it is oscillated in this manner. Okay, first of all we need to prove that it is an SHM. Alright, what we do is we displace it slightly and we leave it, so it is going to oscillate like this. So first of all we need to prove it this is an SHM and then find the time period of the SHM. Okay, now first step is to find the equilibrium position. Where would be the equilibrium position of the pendulum? Right here. Very good. Now what we need to do is we need to displace it by a distance x. So we displace it by a distance x. Okay, let's call this angle theta. We displace it by a distance x and let's call this angle theta. Okay, now at this position what we need to find out is we need to find out the net restoring force. We need to find out the net restoring force. So restoring force means the force which is going to take it in this direction. Is that correct? Okay, so what are the forces acting? Mg, tension. Okay, if this angle is theta, this angle will also be theta. So this would be mg cos theta and this would be mg sin theta. Is that clear? So what is the net restoring force? The net restoring force is mg sin theta. Is that correct? So can I write F is equal to minus mg sin theta? Why minus mg sine theta? Because I've displaced the particle towards the left and the net force is towards the right. So I can write it as F is equal to minus mg sine theta. Is that correct? Okay. Now tell me, is this an SHM? कौन बोला? क्यों? क्यों? To what? What is displacement? Sine theta is displacement. Okay, चलो ठीक है. So F is equal to minus mg. You said sine theta can be replaced by x upon x square plus L square. Done. Is this an SHM? Is this an SHM? Minus है लेकिन is it proportional to x? No, it is not an SHM. Yes, so that approximation we'll have to take. But in this form, is it an SHM? It is not an SHM. Okay. Now what approximation we are taking? We are taking that theta is very small. Sorry? Yeah, about that. So if theta is small, I can replace sine theta by theta. Have you done this? If theta is small, you can replace or approximate sine theta to theta. Okay. Now from here, if this theta is very small, this arc length and this displacement are almost the same. So can I write theta is equal to x by L? This will be the arc length divided by the radius. Okay. But because this theta is very small, this arc length and this displacement, this chord, are almost of equal lengths. Alright. So theta I can replace by x by L. Now I can substitute it over here. So this will be minus mg into, and for theta, sine theta I'll substitute theta, and which is x by L. Is that clear? Okay. Now is it an SHM? Yes. Now it is an SHM. So always remember, for a simple pendulum, it is an SHM only for very small angles. Alright. Less than 4 degree. Is that clear? Okay, I don't know if you have done this experiment in lab. You have done this? Alright. So to find the time period, you oscillate it and you calculate the time. So when I was doing this experiment when I was in school, I was doing like this. मैं खेल रहा था basically. तो ये उधर से आके मेरे को पीछे लगाता है एक. Alright, so it has to be for very small angular displacements. Is that clear? Okay. Okay, so from here, can I find the acceleration? The acceleration would be minus g by L into x. So what is omega square? Omega square is g by L. So what will be the time period? The time period would be 2 pi under root of L by g. Is that clear? You already know this. 2 pi under root of L by g. But now you know how it comes and what is the assumption. What is the underlying assumption? Is that clear? Good. Okay, so with mechanical systems, we can have many situations in which a particle is executing SHM, and we'll see a lot of different kinds of situations, a lot of weird, complicated situations. But that is when we come back to SHM. Right now, what I want to do is I want to do superimposition or the superposition principle and composition of SHMs, which is what we are going to use in waves. Alright, that is very important part of waves, the interference of waves. Alright, so that will be used in wave on a string, that will be used in sound waves, that will be used in light waves. Alright, so एक बार पढ़ लो, 3 chapter के लिए आराम हो जाएगा. Alright, so that concept we are going to use again and again. Okay, so understand that concept very nicely. So this is superposition of two SHMs. Alright, suppose there is a force which is acting on a particle such that it is executing SHM. Alright, so if a force is executing SHM, I can write F1 is equal to d square r1 upon dt square. Sorry, if f is a force which is executing SHM, alright, if f is a force which is executing SHM, then one sec, yeah, if f is a force which is executing SHM, alright, and its position is, let's say, r1, so f1 is the force and position is r1. Okay, what can I write f as? I can write f is equal to m into d square r1 upon dt square. You get this? What is this? This is the acceleration. Okay, this is the acceleration. So this m multiplied by the acceleration. Okay, so suppose this is f1 and there is another force because of which a particle is executing SHM. So for that I can write is that correct? Okay, so this is equal to, let's say this is equal to what's your, so I can write it like this. So if it is an SHM, this is equal to this. Okay, so from here, if both these forces are acting on the same particle simultaneously, if both these forces are acting on the same particle simultaneously, what can I write? The net force will then become equal to what? F1 plus F2. The net force will become equal to F1 plus F2, and that will be equal to m of d square r1 upon dt square plus d square r2 upon dt square. Is that clear? Okay, so what does this tell me? It tells me something about superposition principle. Alright, so what is superposition principle? Superposition principle tells me that there is a particle on which only one force is acting, and that is making it execute an SHM. Alright, so it will have displacements relative to time. Okay, and then there is another force which is acting on the particle, and the first force, suppose the first force now is not acting, only the second force is acting on the particle. So it will also make the particle oscillate, and there will be some displacement of the particle. Okay, now if two forces start acting simultaneously on the particle, the net displacement of the particle will be equal to the displacement which individual forces would have produced. Alright, that means what? The net force on the particle, or the net displacement of the particle, R, will be equal to R1 plus R2. Alright, what is R1? R1 is the displacement of the particle if only F1 would have been acting. And what is R2? R2 is the displacement of the particle if only F2 would have been acting. Alright, so if both the forces are acting simultaneously, the net displacement of the particle will be equal to the algebraics, or the, because it is displacement, the summation of both these displacements. Is that clear? Okay, that is the superposition principle. You understand it? That is the superposition principle. So what do we observe here? We observe here is if two particles, if a particle is executing SHM, and it is executing SHM on the influence of two forces, or two or many forces. Basically what we are talking about is a composition of SHM, or a superposition of SHM. So on the same particle there is one force which is making it oscillate, and there is another particle which is also making it oscillate simultaneously. So in this case what we are doing is we are superimposing two SHMs, or we are adding two SHMs. Okay, so the resultant of these two SHMs, and we'll see that, will also be an SHM, but with a different phase. Alright, we'll see that. Will be a with be another SHM but with a different phase. Alright, and that is what we want to derive right now. Alright, composition of two SHMs. Alright, so suppose the first SHM is given by x1 is equal to a1 sine omega t, and the other SHM is given by a2 sine omega t plus delta. Okay, so what is the phase difference between these two particles? The phase difference between these two particles is delta. The phase difference between these two SHMs is delta. Okay. Now what does principle of superposition say? The net displacement of the particle will be equal to the sum of the displacements individual forces would have produced. So x should be equal to what? X should be equal to x1 plus x2. Is that clear? So x should be equal to a1 sine omega t plus a2 sine omega t plus delta. Okay, and now we are going to manipulate it trigonometrically. And how we are going to do that? Something like this. So this will become a1 sine omega t. Now open this bracket. So basically this is sine a plus b. So what is sine a plus b? It's sine a cos b plus cos a sine b. Is that correct? Okay. Now what we're going to do is we're going to take sine omega terms together and we're going to take cos omega t terms together. So this is going to give me a1 plus a2 cos delta into sine omega t, and this is going to give me what? This is going to give me a2 sine delta into cos omega t. Is that clear? Any problem? Okay. Now what we're going to do is we'll assume cos, let's call this what? Let's call this epsilon. Let's call this a2 sine delta. No, not yet, not just yet. Wait, hang on. So this is some constant into, so this is a constant term, so some constant into sine omega t plus some constant into cos omega t. Okay, and I want to convert it into one sine term. Alright, have you done this in trigonometry? I think you would have. Anyway, let's do it over here. So what we are going to do is we'll replace it by c. So we'll replace it by c sine omega t, and we'll replace this by d cos omega t. So what is the substitution? The substitution is c is equal to a1 plus a2 cos delta and d is equal to a2 sine delta. Alright, we substitute this. Now what we're going to do is we're going to multiply and divide both these equations by under root of c square plus d square. And in a minute you will understand why. We're going to divide both the this equation. Basically we're going to multiply the numerator and denominator by under root of c square plus d square. Okay. Now what we do is we call d upon under root of c square plus d square is equal to sine epsilon. Okay. Now this quantity d upon under root of c square plus d square, is it a quantity less than 1? D upon under root of c square plus d square, is it a quantity less than 1? Absolutely, it's a quantity less than 1. So can I substitute by sine epsilon? So epsilon can be any angle, the sine of which is equal to d upon under root of c square plus d square. Alright, okay. Now using this, just find out what is cos epsilon. Cos epsilon would be 1 minus under root of this term, under root of 1 minus n square of this term. So if you do that, what would you get? You are going to get c upon under root of c square plus d square. So with this substitution, what does it become? If this becomes this term, I assume it to be sine epsilon, this term will be cos epsilon. Is that clear? So I'm going to write under root of c square plus d square, and then I can write it as sine omega t cos epsilon plus cos omega t sin epsilon. Now do you understand where I'm going from here? क्यों है? मेरा मन माने ऐसा मान सकते हो, कॉस एप्सिलन भी मान सकते हो, कोई प्रॉब्लम नहीं है, कॉस एप्सिलन भी मान सकते हो, बट फर्क नहीं पड़ता है, बस इक्वेशन में एक फेज डिफरेंस आएगा और कुछ नहीं. You can assume it to be cos epsilon, no problem. Alright, because I want to convert this in terms of sine. Agar if I convert this in terms of sine, then comparing with this equation, I can directly get the phase difference. That is the objective. Alright. Okay, so I want to convert this in terms of sine. So what is this? Is this sine A cos B plus cos A sin B? So this is basically what? Sine A plus B. So I can write x is equal to under root of c square plus d square into sine omega t plus epsilon. Okay. Now we are going to write it as x is equal to a sine omega t plus epsilon. Now this term a is under root of c square plus d square. Is that clear? Any problem? Okay, so the resultant of these two SHMs, what does it come out to be? An SHM. Alright, the resultant of these two SHMs comes out to be another SHM. But what is the amplitude of that SHM? It's A. And what is the phase difference of the resultant SHM with respect to the first SHM? It's epsilon. Is that correct? Alright, so I need to write this equation in terms of A and epsilon. Is that clear? Now from this equation, what do you understand? What is A? From this equation, what is A? A is the amplitude. Oh, phasor देके radius बोला क्या? Okay. A is the amplitude. And what is A? Under root of c square plus d square. So amplitude is equal to under root of c square. What is c square? A1 plus A2 cos delta ka square plus what is d square? D square is A2 square sin square delta. Alright, now you expand this term. You'll get A1 square plus A2 cos square delta plus 2 A1 A2 cos delta. A2 cos square delta and A2 sin square delta will give you A2 square. So finally A will come out to be A1 square plus A2 square plus 2 A1 A2 cos delta under root. That is the amplitude of the resulting SHM. Is that clear? Amplitude of the resultant SHM. Okay, how do I find out epsilon? Now divide these two quantities. You're going to get tan epsilon, and tan epsilon would be equal to what? Tan epsilon is equal to d by c. So that is A2 sin delta divided by A1 plus A2 cos delta. Yes. Yes, correctly observed. Okay, so what is the resultant of two SHMs which have a phase difference of delta? The resultant would be A sin omega t plus epsilon, where A is the amplitude and the amplitude would be given by this A1 square plus A2 square plus 2 A1 A2 cos delta. Alright, and the phase difference with the first SHM, the tan of that will be given by A2 sin delta divided by A1 plus A2 cos delta. Alright, so we can superimpose two SHMs and we can find the SHM of the resultant motion of the particle. Is that clear? Any problem? Okay, now does this ring a bell? Have you seen this kind of result anywhere? Absolutely, you have seen this result in vectors. Okay, so if you have two SHMs, if you are combining two SHMs, you can use this. Alright, you can use this. You can find the resultant amplitude, you can find the phase difference. Alright, suppose you are going to add three SHMs. Now you have sine omega A1 sine omega t plus A2 sine omega t plus delta 1 plus A3 sine omega t plus delta 3 or delta 2. Alright, you have to combine these three equations. It's going to be very rigorous, or it's going to be very difficult to combine those three equations. If I had two sine terms, 3 board bhara tha. ठीक है, if I have 3 sine terms, I don't know kitna board bharega. Anyway, it's doable, but it's going to be very rigorous. Okay, so what this mathematics tells me is, if you want to combine two SHMs, or you want to find the resultant of two SHMs, do one simple thing. So if I have x1 is equal to a1 sine omega t, and I have x2 is equal to a sine omega t plus delta. So do one simple thing. Assume that the amplitudes are vector. Assume that the amplitudes are vector. So the first amplitude, the amplitude of the first particle, I'm going to draw as a vector. Okay. And then the second amplitude, I'm going to draw as a vector, but with a angle of delta between them. Okay, because the phase difference is delta, I'm going to make an angle delta between them. So if this is d2, a2, this will be delta. So the second vector or the second amplitude I'm going to draw with a angle delta between them. Alright. What will be the resultant of these two SHMs? The resultant amplitude will be equal to the vector summation of a1 and a2, and that's the exactly result you found over here. Is that correct? So the resultant, the amplitude of the resultant SHM would be the vector summation of these two amplitudes. Alright, and what is this angle? This angle will be epsilon. Basically the resultant is making an angle epsilon with the first one. That means what is this epsilon? Epsilon is the phase difference of the resultant SHM with the first SHM. Okay, and through vector what we know is tan epsilon would be equal to a2 sine delta divided by a1 plus a2 cos delta. Exactly the result we have seen. Is that clear? So to combine two SHMs, all you need to do is assume amplitudes to be vectors and draw those vectors with the phase difference being the angle between the vectors, and simply find the resultant. Is that clear? The resultant magnitude is going to give you the amplitude, and the angle it makes with the first vector is going to give you the phase difference with the first vector of the resultant SHM. Is that clear? Now you can extend this result to 3, 4, 5, 6, 100 of SHMs. Alright, because vector summation is easy. You can easily do vector summation. Is that clear to everyone? And that is how we are going to deal with superposition of SHMs. Okay, now important thing, am I saying amplitude is a vector quantity? Yes, no. Am I saying amplitude is a vector quantity? Absolutely not. Amplitude is a scalar quantity. It's not a vector quantity. But the mathematics is such that if you assume them to be vector quantities, you're going to get the right answer. That is it. I'm in no way saying or telling you that amplitude is a vector quantity. Is that clear to everyone? Any problem? Good. So note this down and remember this, and this is going to be used again and again and again. Is that clear? Okay. Now let's go forward with this result. There is something known as constructive interference. Alright, there is something known as constructive interference. What do you mean by constructive interference is, two particles are oscillating. Okay, if the phase difference is such that the amplitude increases, the amplitude of the resultant SHM increases, that is known as constructive interference. They are interfering constructively, so that the amplitude of the resultant SHM is going to increase. Alright, and destructive interference means that the amplitude of the resultant SHM is going to decrease. Alright, that is, and we will discuss these terms in larger detail, in greater detail when we go to waves. But right now just understand, if the amplitude is increasing, it's constructive interference, and if the amplitude is decreasing, it's destructive interference. Okay, so from this equation, if it is a constructive interference, so constructive interference means the amplitude will be maximum. The amplitude will be maximum. When can I have the amplitude maximum? When a1 is equal to a1 plus a2. That is the maximum of these two. If you assume them to be vectors, what is the maximum magnitude, the maximum magnitude of the resultant. It's a1 plus a2. And when does this happen? When delta is equal to 2n pi. 0, 2 pi, 4 pi, 8 pi, 6 pi. Is that correct? So that is constructive interference. If I'm talking about destructive interference, alright, so the resultant amplitude in that case would be a1 minus a2, and I'll put a mod sign because I don't know if a1 is greater or a2 is greater. Okay, and this happens when delta is equal to not n pi. 2n plus 1 pi. Pi, 3 pi, 5 pi, 7 pi. At these places you'll have destructive interference. Basically you have constructive interference but when this becomes 1, and you'll have destructive interference when this becomes minus 1. That's it. Is that clear to everyone? Alright, so quickly write down one question. x1 is equal to a sin omega t. x1 is equal to a sin omega t. A sin omega t. x2 is equal to a sin omega t plus pi by 3. x2 is equal to a sin omega t plus pi by 3. So these are the two SHMs which are simultaneously acting on a particle. Alright, okay. Write the first part. Find the displacement at t is equal to 0. Find the displacement at t is equal to 0. Find the displacement at t is equal to 0. Part B. Find Vmax. Find Vmax, the maximum speed of the particle. And part C. Find Amax. Okay, before that, where we have derived the equation of resultant SHM, write that in again with a note. Alright. This is only valid, this result is only valid for particles executing SHM with the same frequency. Alright, if two SHMs have the same frequency and they get superimposed, then only this result is valid, otherwise it's not. So in both the equations, what did I write? Sin omega t and sin omega t plus delta. That means the angular frequency for both the SHMs would same. If it is not same, then the phase difference between them would not be a constant and you're not going to get this result. Is that clear? Okay. Now you attempt this question. Root 3 by 2a, yes. What is the equation of the resultant SHM? √5. 5 नहीं आएगा, √3 आना चाहिए. √3a omega t plus pi by 6. Correct. So all you need to do is find the resultant of these two SHMs, isn't it? So that's how you're going to find the resultant. A. So this would be a square plus plus 2a into cos pi by 3. So the net amplitude or the resultant amplitude will be equal to √3a. Is that correct? Okay, and since both of them have equal magnitude, the resultant would go from, the resultant would be along the angular bisector. Alright, so this is √3a, and what is the angle it is making with one of the SHMs? Pi by 6. Alright, so your equation will become x is equal to √3a into sine omega t plus pi by 6. Is that correct? Okay, so what do you need? You need at t is equal to 0, x will be equal to √3a sine pi by 6. How much is sine pi by 6? Half. So this will be √3a by 2. Any problem? Just substitute t in the equation. Okay. Next, what do you need? Maximum speed. Maximum speed is what? Amplitude into omega. So V max would be equal to the amplitude, which is √3a into omega. You need A max. What is A max? Omega square A. So what is A? A is √3a multiplied by omega square. Is that clear? Next question. Three SHMs of equal magnitude A, magnitude nahi, amplitude. 3 SHMs of equal amplitude A and equal time periods in the same direction combine. In the same direction combine. Phase of second is 60 degree ahead of first. Phase of second is 60 degree ahead of first, and phase of third is 60 degree ahead of second. Yeah, 60 degree ahead of second. 2 is ahead by 60 degree from 1, and 3 is ahead 60 degree from 2. Is that clear? Find the amplitude and phase. Find the amplitude and phase difference with the first SHM. Find the amplitude and phase difference with the first SHM of the resultant motion. Yes, precisely. Second, 60 degree ahead of first. Third, 60 degree ahead of second. Amplitude 2a. No, he is talking about the answer. 5/6. Yes. Done. So all you need to do is a vector summation of 3 vectors. याद है वेक्टर ऐड करना? भूल गए? Okay. First vector, the second vector is 60 degree ahead of phase, and the third vector is 60 degree from this one. And what will be the resultant? The resultant would be something like this, and that's what you need to find out. Alright, how do you do this? So अगर थोड़ा सा geometry use करोगे तो you will see that what would you see? You'll see that this becomes an angle, these two becomes parallel lines. कैसे? This angle is how much? If this is 60, this is 60, and this is 120. Alright, so if this is 60, this angle would be how much? So what will be this angle? नहीं ये नहीं पता है ना, sorry, ये नहीं पता है obviously. So this is 120, this is 120, and then what we can do is, हाँ isosceles trapezium. Yeah, this length and this length is same, and these angles are same, so this is an isosceles trapezium. So this angle has to be, sorry, this line has to be parallel to this one. So this would be 60 degree. Alright. How does that help? ठीक है, ये मिल गया ना. So if this is also 60 degree, now it's very simple, either perpendicular गिरा. So this would be how much? A cos 60 degree, मतलब A by 2. This would be A, and this would be A cos 60 degree, यानी कि A by 2. So the resultant is 2A. The amplitude is 2A, and what is the angle it is making with the first one? 60 degree. Is that clear? और अगर this is, you find this complicated, then कुछ दिमाग मत लगाओ, xy axis पे डाल दो. This is the first vector A, the second vector is at 60 degree, the first vector would be at 120 degree, मतलब this would be 60 degree. That's it. कुछ दिमाग मत लगाओ, सीधे इस पे डालो. Alright, is that correct? 120, yes, this will be 60 degree. So इसका a cos 60 degree और इसका a cos 60 degree cancel हो जाएगा. इसका a sin 60 degree, a sin 60 degree. ठीक है, a sin 60 degree, a sin 60 degree मतलब कितना हो जाएगा? रूट 3 है. Sin 60 degrees root 3 by 2. So root 3 by 2 and root 3 by 2 will get added. So you will have this root 3 by 2a and you will have this as a. Correct. So the resultant of this would be this square plus this square and you will get 2a. And tan you will take this divided by this, whatever, tan alpha. कहाँ पे? Sorry, root 3. Sorry, my bad. Tan alpha will be equal to root 3a upon a, मतलब root 3. So this will be equal to 60 degree. Is that clear? ठीक है. Or you could have solved this question orally. How you could have solved this question orally? दिमाग भी नहीं लगाना था, मतलब दिमाग तो obviously लगाना था, दिमाग ही लगा के solve होगा. So what is the angle between this vector and this vector? Is it 120 degree? And two vectors when inclined at 120 degree and have the same magnitude. What is the resultant? हाँ वो तो होगा ही, because equal vectors. But what will be the magnitude of the resultant? It will be a. Remember this result: a square plus 2a into a, and if delta or theta becomes 120 degree, so this will be how much? This will be minus a by 2. अरे minus 1 by 2 बाबा. Alright, so you'll have a square plus a square minus a square. So you'll have the resultant will be equal to a. So if two vectors of equal magnitudes inclined at 120 degree, the resultant would be the same as the magnitude of either one. Is that correct? And obviously if two vectors are along this are equal in magnitude, the resultant would be along the angle bisector. तो इन दोनों का resultant क्या होगा? इन दोनों का resultant ये होगा, और उसमें क्या ऐड करना है? ये वाले को ऐड करना है. So this becomes 2a and the angle with the first one is 60 degree. Correct? Okay. Last question for the day. हाँ? और नहीं है? और नहीं है मतलब? अभी और नहीं है. This is the last one for the day. Okay. x1 is equal to 2 sin 100 pi t. x1 is equal to 2 sin 100 pi t. x2 is equal to 2 sin x2 is equal to 2 sin 120 pi t plus pi by 3. x2 is equal to 120 pi t plus pi by 3. Find the displacement of the particle. Find the displacement of the particle at t is equal to 0.0125 second. Find the displacement of the particle at t is equal to 0.0125 second and t is equal to 0.025 second. T is equal to 0.0125 second and t is equal to 0.025 second. करेक्ट है? सोचो. t is equal to 0.025 second in the second case. ठीक है? Find the displacements. Find the displacement of the particle. दोनों का फ्रीक्वेंसी अलग है, बिल्कुल सही बात. फिर क्या होगा? तो जल्दी करना, जल्दी क्वेश्चन सॉल्व करना. What will be the amplitude of the resultant SHM? 2 root 3. Sure. How come? A square plus 2 a square cos delta लगा दिया. हाँ. What will be the resultant amplitude? हाँ, डिस्प्लेसमेंट सिर्फ पूछ रहा है. सही बोल रहा है. क्यों लंबा होगा? x1 is equal to what? 2 sine what? 100 pi t. And x2 is equal to 2 sine, what's that? 120 pi t plus pi by 3. Alright, listen up. Very important. Both the equations have different angular frequency. That means the phase difference would be variable. The phase difference between them will not be a constant. It will be a function of time. That means when they superimpose, the amplitude of the SHM is going to change according to the phase difference between them. So they are going to have a varying amplitude if they are superimposed. Okay, so I cannot write one equation to define this. I cannot write one equation to describe the resultant simple harmonic motion. But is it necessary I do that? It's not. Why? Because the principle of superposition is anyway valid. The principle of superposition is always valid. So what does the principle of superposition tell me? X will be equal to x1 plus x2. That's it. So all you need to do is find the displacement at that time and find this displacement at that time and add them. That's it. That's all you need to do. Is that clear? Okay. So this would be what? 2 sine 100 into pi into what is t? 0.0125 plus this is equal to 2 sine 120 pi into 0.0125 plus pi by 3. Okay, so this becomes what? This becomes this is 1.25 1.25 pi. So 1 by 1.25 pi is how much? Huh? 1.25 pi. 1.25. How much is 1.25? 5 by 4 na? So this is 2 sine 5 pi by 4. ये कितना मुश्किल है निकालना? बहुत बहुत मुश्किल है. सब मार खाओगे. हाँ 0 पॉइंट वो तो सेकंड केस में. हाँ तो फाइनली बताना क्या आता है इन टर्म्स ऑफ पाई. Okay, 0.0125. How much is that? Is that 1 upon 4 is 1 by 80. This will be 1 by 80. Okay, so this becomes what? 120 pi upon 8 plus pi by 3. तो ये कितना होगा? So this is 4 2. This is 4. So this is 8. 3 pi by 2 plus pi by 3. So this becomes 2 sine. First of all, this is what? This is 5 pi by 4. Matlab pi plus pi by 4. And this is 2 sine 3 pi by 2 plus pi by 3. 11 pi by 6. So 11 pi by 6 is how much? क्यों लगाना यार वो? 11 pi by 6. 11 pi by 6 would be 11 pi by 6 would be equal to 5 pi plus pi by 6. नहीं नहीं 5 pi Mm. So what did you say? 11 pi by 6 ना? Pi plus 5 pi by 6, वही तो ठीक है. Or we can write it as what? 2 pi minus how much? 2 pi minus pi by 6. वो better रहेगा ना? 2 pi minus pi by 6. This will be better. So pi plus pi by 4 is what? Sin pi plus theta is minus sin theta. So this become minus 2 into sin pi by 4 would be 1 by root 2. Plus 2 into 2 pi sin 2 pi minus theta is minus cos theta. Sorry, minus sin theta. Minus sin theta. 2 pi minus theta is minus sin theta. So this will become minus sin pi by 6 is what? That will be the resultant. Is that clear? Important thing is, even if you cannot find the equation of SHM, resultant SHM, because the angular frequencies are different, still the principle of superposition is very much valid. Is that clear? Similarly, you can solve for the second part. And that's it for the day. Next class, we'll start waves. Yes. बहुत कुछ है. अभी तो बस